Welcome to today's lesson on Unit 5, Day 3 notes, factoring by grouping. So this time we're going to be working with polynomials with 4 terms. So anytime a polynomial has 4 terms, we factor by grouping. Now factoring by grouping is a method of factoring out the GCF multiple times. So the last time we talked about factoring was factoring by the greatest common factor, right? So if I were to give you an example, let's say 2x squared plus 12x, we need to figure out what the greatest common factor between 2x squared and 12x is. So the GCF would be 2x. And how we format the answer is the GCF is going to be in front of the remainder. So the remainder would be the stuff inside of the parentheses, right? Since the GCF is 2x, I'll write 2x in front of the parentheses. Now, remember, how we approach this was we look at the GCF and play the algebra game. And that would be 2x times what gives you 2x squared. And you would say x. And then 2x times what gives you positive 12x. And you would say plus 6. So this right here is the expression in factored form, and that would be our answer. So let's look at a different example where this time the first term is negative. So if I were to give you something like negative 2x squared plus 12x, now here's the thing. When we're trying to find the GCF, if you notice that there is a negative in the first term, you have to factor that out. Okay, so I'll put negative right here, and then I'll look at 2x squared and positive 12x. What is the largest number that goes into these two numbers at the same time? And you would say 2x. So the GCF is negative 2x. So I have negative 2x times my remainder. So negative 2x times what gives you negative 2x squared? You would say x. And then negative 2x times what gives you positive 12x? Well, remember, a negative times a negative gives you a positive. So it's negative 2x times negative 6. That'll give you positive 12x. So this would be the answer. Okay? Now, before we factor by grouping, what we need to do is learn how to factor out the common polynomial. So if I look at number 1, I have 5x squared times the quantity of x minus 2 plus 3 times the quantity of x minus 2. So 5x squared times the quantity of x minus 2 would be my first term, and that'll be in pink. And then we have positive 3 times the quantity of x minus 2. That's my second term, and that'll be in green. Now notice that the term in pink and the term in green have the same polynomial, that x minus 2. So that x minus 2 is the GCF. Now if you remember, it's GCF first times the remainder. So since the GCF is x minus 2, then the GCF is going to be first, and then what's left over. So x minus 2 times what gives you 5x squared times the quantity of x minus 2. Now notice I said 5x squared times the quantity of x minus 2. So since we factored out the x minus 2, we have 5x squared left in this term here, right? So I'll just write 5x squared, and we don't even need this anymore. Okay? So x minus 2 times what gives you 3 times the quantity of x minus 2? That would be x minus 2 times 3. Okay, so 3 is left over. So your answer is x minus 2 times the quantity of 5x squared plus 3. All I did was I got rid of the x minus 2 here and also there, and then I will put what's left over inside of this parentheses. Okay? Number 2, 7y times the quantity of y minus 5 minus 3 times the quantity of y minus 5. So here's our first term, and here's our second term. What do they have in common? They have y minus 5 in common. So the GCF is y minus 5. So y minus 5 times the quantity of what's left over. So 7y minus 3. Number 3, 11x times the quantity of x minus 8 minus x minus 8. Okay, so we have our first term and then our second term. What do these two terms have in common? An x minus 8. So the GCF is x minus 8. So x minus 8 times the quantity. So what's left over? That would be 11x and that negative 1. Alright, so x minus 8 times the quantity of 11x minus 1. So that's basically what we're trying to do. We want to have these matching polynomials before we take the GCF out, okay? So that's going to be very, very important when we factor by grouping. So to factor by grouping, you will need to group the polynomials into 2 groups and factor out the GCF from each group. Then you can factor just like the above examples. So let's take a look at number 4. N cubed plus 6n squared plus 5n plus 30. The idea is that you group the first 2 terms and the last 2 terms, and you want to include the sign inside of the parentheses. So we're going to look for the GCF of this first group here. So let's find the GCF. So what is the largest factor that goes into n cubed and 6n squared at the same time? And that would be n squared, because n squared is the largest factor that goes into n cubed and 6n squared at the same time. Alright? Now, let's take a look at this second group here. Now, the GCF of the second group would be positive 5. So since there's a positive sign here, I just want to remind myself by writing positive 5 as we put it all together. So let's go ahead and build. We have n squared times my remainder, alright? And then positive 5 times my remainder. So n squared times what gives you n cubed? That would be n. N squared times what gives you 6n squared? That would be plus 6. Now looking at this, we have our GCF being 5. So 5 times what gives you 5n? And you would say n. 5 times what gives you 30? And you would say plus 6. Now look at that. We have n squared times the quantity of n plus 6 plus 5 times the quantity of n plus 6. Basically what we did for the first 3 examples. So notice that this first term and this second term have an n plus 6. So that would be the GCF of this polynomial. So n plus 6 is the GCF, and then we look at the leftovers. So that would be n squared plus 5. Number 5, n cubed plus 7m squared minus 2m minus 14. So again, we'll group the first 2 terms and the last 2 terms. And since there's a negative in the third term, when we group that, we need to make sure that that sign is inside of the parentheses. Alright, so let's find the GCF of the first group. The GCF would be m squared. For the last group, the GCF would be -2. Okay, so hopefully we remember at the beginning, if you have a negative in the first term, so yes, this is the first term of this group. So you need to factor out that negative, and then you should be good to go. So the greatest common factor is a -2. So we're going to go ahead and build our answer. So the GCF for the first group is m squared, and then the GCF of the last group is -2. Okay, so m squared times what gives you m cubed? You would say m. M squared times what gives you 7m squared? You would say +7. Now, looking at the last group, the GCF again is -2, so -2 times what gives you -2m? That's m. -2 times what gives you -14. Well, a negative times a positive gives you a negative. So -2 times +7 is -14. Okay? So, what do they have in common? They have an m plus 7, right? So we're basically going to factor the m plus 7 out, and then we're going to multiply by what's left over, and that would be n squared minus 2. And there you go. Number 6, 9x cubed plus 9x squared minus 7x minus 7. So we'll group the first two terms and the last two terms. The GCF is 9x squared for this first group, and for the second group, the GCF is, there's a negative, right? So the GCF should be a negative something, so it would be -7. So we have 9x squared and -7. So 9x squared times what gives you 9x cubed? That would be x. 9x squared times what gives you positive 9x squared? You would say +1. For this last group, -7 times what gives you -7x? Well, that would be x. -7 times what gives you -7? That would be +1 or +1. So they have an x plus 1 in common, and that's what I'm going to factor out. So x plus 1 times my remainder, and I have 9x squared minus 7. So this is my answer. Number 7, x cubed plus x squared plus x plus 1. So we'll group the first two terms and the last two terms. So the GCF for the first two terms is x squared, and the GCF of the last two terms would be, so this one's a little tricky. What's the largest number that goes into x and 1 at the same time? Now if you remember, there's an invisible 1 in front of this x. So the largest number that goes into 1x and +1 at the same time would be 1. So we have x squared times my remainder. This should be a +1. So +1 times this remainder here. So x squared times what gives you x cubed? That would be x. X squared times what gives you x squared? That would be 1. So we have x plus 1 as our remainder. Now for the last two terms, we have the GCF of +1. So what's inside is going to be x plus 1, right? So 1 times x is 1x, and 1 times +1, of course, is 1. So let's factor again. What they have in common is an x plus 1, so we'll factor that out. So what's left over is the x squared plus 1. And there you go. Number 8, y squared plus y plus xy plus x. So, bunch of variables here, but that's okay. We're going to group the first two terms and the last two terms. So, the GCF between y squared and y is y. And the GCF of xy plus x, what do they have in common? Well, they both have an x, right? So the GCF between the two is x. So we're going to build. So the GCF here is actually positive x, if that's okay. Y times what gives you y squared? That's y. Y times what gives you positive y? That would be 1. Now, the GCF here is plus x, right? So positive x times what gives you positive xy? That would be y, because x times y is xy. Now positive x times what gives you positive x? That would be 1. So we can factor out the y plus 1 out, and what we're left with is y plus x. And that's the answer. Okay? Number 9, we have x cubed minus 6 plus 2x minus 3x squared. Now, we need to be very careful with this problem because this expression is not in standard form, meaning the exponents are not going from high to low. So if we look at all of these examples here, this one is going from high to low, high to low, high to low, but this one is not. So we're going to have to rearrange this before we start grouping. The highest exponent is 3, so it's x cubed, and then what's the next highest exponent? That would be 2, right? So we will write negative 3x squared. Since the negative is attached to the 3x squared, we have to write that as our next term. And then what's the next term after that? Well, the next exponent would be 1, right? And this, that 2x, has an exponent of 1. So that's going to be after the negative 3x squared, so positive 2x. And then lastly, we have our constant, which is negative 6. Okay? So x cubed minus 3x squared plus 2x minus 6 is in standard form. Alright, so we'll group now. We'll group the first two terms and the last two terms. The GCF is x squared, and the GCF for 2x minus 6, that would be positive 2. So x squared times my remainder plus 2 times my remainder. X squared times what gives you x cubed? That's x. X squared times what gives you negative 3x squared? That is negative 3. And looking at the last terms here, positive 2 times what gives you 2x? That's x. And positive 2 times what gives you negative 6? That is negative 3. So we'll go ahead and factor out the x minus 3. And then write what's left over. So it's x squared plus 2.